Let's go through Liquid 1438, longest continuous subarray with absolute difference less than or equal to limit. For this question, it give us the integer array nums and also our integer limit. It let us find the longest subarray, which any pairs in the subarray has the absolute difference that is less than or equal to limit. And we find the longest subarray, we return its length. So for this question, we can iterate any two start end of a subarray, right, left, right. But the thing is that we find this kind of if for example we have a right and left, and instead of iterate any pairs of it from this left to right, we can just find the min and max, right, in this range. So if the max minus min is smaller than limit, then this kind of left and the right, they satisfy the condition, right? So the right minus left plus one will be one of the candidate. So we iterated the right pointer and we move the left pointer. If done set meet the condition, just keep it moving, right, until it satisfies condition. So this is some kind of classical two-point problem. For the find the mean and the max value in this kind of range sliding window, we can use a monotonic deck, right? And actually, because use a tree set or heap, the time complexity will be n log n, right? And use monotonic deck, and the time complexity will be O n, right? So we just write code for this, right? We need let's have int n equals num stop time length, and we need a left pointer, um, and we need to have for example, result, result 0. So we need a deck integer. We have min q equals new array deck. And max q equals new array deck, right? So what we do is that for int right equals to 0, right, smaller than n, right, plus plus, right? So for this kind of because the min and max include current right index, so we'll write a while loop, right, to pull from the right those kind of conditions, right? We need to manipulate both the min q and max q. After that, we add the right index to that, right? So that is the first step. The second step is using the while loop to shrink to move the left pointers, right? So we'll say while nums max q dot peak first minus nums, because after first while loop we are going to add a number into our max q and min q, so they will never be empty, right? So those can peak first is the min or max value, right? Min q dot peak first. If this one is greater than limit, right, then we'll have left plus plus. Okay. And also, if we move the left pointer, we need to check the those kind of on the left, pick left, whether the left pointer is on the on the deck, the leftmost side, right? So if it is, we need to pull from the left about that index. And here we write result was a mass of max result right minus mean left plus one, right? And in the end return result. But the thing is that we know for this kind of two pointer, right and the left pointer, um, we'll say in actually we don't need a while loop, right? As long as those can we satisfy the condition. Um, if it doesn't satisfy the condition, right? Because um, then we just move our left pointer, keeping the original windows, right? We don't shrink, so that the window size will never change smaller. So what we write, we can change this kind of while loop to if. Uh, so if and we don't need this kind of result variable, just return right minus left. So in this case, we also need let's have left equals 0, right equals 0, right? We don't need the result variable, so we don't need this line. So let's write the deck part. So while this kind of max Q is not empty, and max Q nums, right? Nums max Q pick right pick the last. If this one is smaller equal to nums, right, that means those kind of index which left in deck will never be optimal for the future calculation, because they will never be max values, right? Because the one thing is that it, even it is equal, right? Because the index is smaller, so they are more likely move out of the sliding window. And if they are smaller, they will never be in the, we can always use the right as a max value, right? So those kind of number, which is in the deck, will never be used for future calculations. We can simply pull from the right. So we have max Q for right. And also we need to have a max Q at the last, the right index. So in this case, um, what's stated in the max Q is in a decreasing order data, right? So they are monotonically decreasing. So this is monotonic Q. So for the what's state they will always have value. What is state on the peak left? That is the max value, right? So also we have while mean Q is not empty and the nums mean Q dot tick last. If this one is greater equal to nums, right? They will never be mean value. So we are simply have mean Q to pull right those kind of index, right? And in the end, we have mean Q at last, right? So here we also need to because the window shrink, the window moved, right? So this is a fixed window sliding window, right? So that means that it is possible the left pointer have already been pulled from for in this while loop. So we should check if um left equals max deck max Q. dot pick first, right? Then what we need to have max q dot pull first. And we'll write if left equals min q dot pick first. Then we're going to have min q dot pull first, right? So this will be our code. This we already have right, so we don't need this anymore. Min q, max q. For last, it's not called for right, for last. And the Python code will be very similar. We need let's have its length, right? N equals the length nums, and we have from the left equals the right equals 0, right? And the max q uh min q equals that right? So we need to import this data structure from collections import deck. So what we do is that while so what we do is for right in range and right. So while max q is not empty, max q and nums max q the pick the last one, right? Pick last is small equal to nums, right? Then we can have max q dot pop, and after while loop we'll always have max q append. This is at last, right? And we'll have min q and nums min q minus 1 if it is greater equal to nums, right? Then we are able we are safely to pop, right? Um this those kind of data in the min q, right? And also min q append, right? So here we don't need to write a while loop. We just use if, right? If nums max q 0 minus nums min q 0. If this one is greater than limit, then we should move our left pointer. So before we move, we check if left equals max q 0, right? Then we need to have max q dot pop left. And we're right. If left equals min q 0, and we also have min q dot pop left, right? And we will always have left should plus equal to 1. And in the end, return right minus left. Uh, For Python, we cannot. There is one of the problem. We should use if we use for loop. When it finished, the right pointer is not at n, it is at n minus one. So right this will be a bit different. So let's write while right smaller than n, right? And we write right pass equal to one. In the end, return right minus left. And this is greater than limit. We so we'll see for this kind of will be ON time complexity because every index is in queue, max queue or min queue once, and the deck did go out of the queue once, either from the right or from the left, right? And the space complexity will also be ON. The worst case is that every index will put on those kind of deck.